Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 8 today, looking at Section 8.2 on reviewing function notation and graphing nonlinear functions. So the objectives in this section are to review function notation, find square roots of numbers, and graph nonlinear functions. And we're still on SLOC, construct graphs of inequalities, linear and nonlinear functions, and conic sections. All right, so in this example, we're going to evaluate a function graphically. So here you have the graph of a function, and we're going to use this graph first to find f of 0, and then to find x such that f of x is equal to 6. So I think I can do this problem without switching over to the tablet. Let me just pull something up here. So let's start with f of 0. I'm going to, okay, let's see. Okay, here we go. So that's asking what is y when x equals 0? So when you're determining that information from a graph, you need to find the point where x is 0. In other words, find a point of the form 0, comma, something. So I think you can see in this case, sorry, this is, I wanted to get my pointer back. There we go. So I think you can see that the point where x is 0 is this point right here. And that is the point 0, comma, negative 2. So if I go back to this, that tells us that f of 0 is equal to negative 2. And it's just that easy. All right, so now going to letter B. Now we want to find a value of x such that f of x is equal to negative 6. So that's kind of the reverse of what we just did. So in this case, we are asking what is x when y is negative 6. In other words, find a point of the form something, comma, negative 6. So if I now try to get my pointer back here. Oh, this is frustrating. Whenever I use the text box, there we go. Whenever I use the text box, it's always really hard to get my mouse pointer back. All right. So y equals negative 6 is down here. It's at the very bottom of the graph. So if I look to my left and look to my right, it looks like there is only one point where y is negative 6. For this type of problem, by the way, there could be more than one answer. So it looks like we're talking about this point right here. The x coordinate of that point would be negative 2. And so just by sheer total coincidence, the answer to this problem is also negative 2, but it's a completely different negative 2 than letter A. In letter A, it was a y value, and in this problem, it is an x value. All right, moving on to the next problem. Use the graph of the function to answer the following. First, if g of negative 2 equals 8, they want us to write the corresponding ordered pair. And then they want us to find g of negative 4. And finally, they want us to find all values of x such that g of x is equal to 0. So this feels like one of those times where you should probably pause the video and try to do as much of this as you can. And of course, I'll be here waiting when you get back so we can compare notes. All right, so let's compare notes. Starting with letter A. If g of negative 2 equals 8, we want to write the corresponding ordered pair. Well, that's really easy. You just have to remember Okay, sorry, I'm having a problem with my mouse again. There we go. So you just have to remember, actually, I'm going to do something different here. You just have to remember that the number that goes into the function is x, and the number that comes out of the function is y. So if they're telling me that g of -2 equals 8, that means the corresponding ordered pair is -2, 8. Notice that you can't really see that point on the graph. It's kind of cut off at the top, up here somewhere. All right, letter B. This is just like one of the problems that we did in the last example. To find g of -4, remember that is the point whose x coordinate is -4. So we find x equals -4. I look up and down, and the only point I see is this point right here, which is -4, -5. Okay, so I just want to make sure you understand how to write this answer. The answer to this question is -5. Okay. So I'm going to write it as a complete sentence, but if you're doing it in your online homework, probably what you would see would be g of -4 equals, and then they would put a box. You just have to put a -5 in the box. All right, and then finally, all values of x such that g of x equals 0. So we're looking for ordered pairs of the form something, 0. So how many points do you see like that? I see 1, 2, 3. All right, so there are 3 answers to this question. Reading from left to right, the first point like that is -3, 0. The second point like that is 0, 0. And the third point like that is 2, 0. So the x values for which g of x is equal to 0 are -3, 0, and 2. All right, that brings us to square roots. So whenever I teach this class face-to-face, I have found that class usually doesn't need me to tell them any of these answers. First of all, there's a corny math joke, square root, get it? All right, so we're going to see what you remember about square roots. Find the following roots. First, we have the square root of 144. Then we have the negative square root of 4/25. And finally, we have the square root of -25. So if you want to pause the video and see how many of those you can bang out, I will be here waiting when you get back. All right, starting with the square root of 144. So remember what square root means. We're looking for a mystery number that when you square that number, you get the number that's given. All right, so in this case, we're looking for a number that when you multiply it by itself, you get 144. Sorry, just want to make sure my text is going to work here. All right, so that number is 12, right? That means that the square root of 144 is 12. All right, next we have the negative square root of 4/25. Give me just a second to try to find, there it is. Okay. So the first question you might have is, what do I do with that negative? And the answer really is nothing. You just let it sit there. So the 2 steps to this problem are, first, find the number that when you multiply it by itself, you get 4/25. That's step 1. And then step 2 is just flip it to the opposite. Okay. All right, so sorry, having mouse problems again. Here we go. Okay. Now, unfortunately, when I type right on the PowerPoint screen like this, I don't really know how to make fractions. So I'm just going to have to do the best I can. Oh, you know what? Actually, I'll do it like this. And this will let me illustrate what I was talking about. So if you start by finding the number that when you square it, you get 4/25. That number would be 2/5, right? Because if you multiply 2/5 times 2/5, you get 4/25. All right, and then what I was telling you about this negative sign is it just comes along for the ride. Okay, so you just put a negative sign in front of your answer, and the negative square root of 4/25 would be negative 2/5. Now, what's the difference between that and something like letter C? Well, in letter C, we would be looking for a number such that when you multiply it by itself, you get negative 25. And if you're kind of scratching your head and thinking, wait a minute, that doesn't really compute, well, then you're exactly right on, because whenever you multiply a real number by itself, the answer will never be negative, right? Because a positive times a positive is positive. A negative times a negative is positive. The closest you could come would be 0, but even 0 times 0 is 0. So the answer is never negative. And for this reason, we say that the square root of negative 25 is not a real number. Now, there is a possibility that you've taken some other math class where the square root of negative 25 does come out to something. We will be looking at those types of numbers at the end of chapter 10. They're called complex numbers, all right? But not right now. All right, right now when they ask you what's the square root of a negative number, you just say it's not a real number. All right, and that brings us to the last part of section 8.2, which is graphing nonlinear functions. These I'm going to do on the tablet. All right, so the first one is, and I actually have all of these written down on the tablet, and they all have the same instructions. So when I switch over to the tablet, we'll probably just stay there for the rest of the time. Graph each function by finding and plotting ordered pair solutions. So we'll start with f of x equals x plus 2 squared. Okay, here we go. So what I'm going to do is make a table. And the thing that kind of takes a little bit of getting used to about nonlinear functions is that it's a little bit less clear what sorts of numbers you should put in. With a linear function, you can really put in any 3 different values of x and get a straight line out of it. The trick with a nonlinear function is you want to pick a big enough variety of x's so that your graph tells the whole story. And you'll see what I mean here in just a second. So, oh, by the way, I figured out a new trick with my tablet. You may or may not be able to see that my graph that I have set up here is a little different from what I used last time. I actually figured out that the program I'm using has this graph paper as a background. So when I draw on it, I don't have to worry about moving it around and messing it up. Okay, so what do I mean by a big enough variety of x values? Well, I'm going to tell you the trick that I use and then try to help you understand why it works. Okay, take a look at that x plus 2 inside this function. All right, I want to pick a variety of x's that sometimes will make x plus 2 negative and sometimes will make x plus 2 positive. So what I like to do is figure out when does x plus 2 equal 0, all right? X plus 2 equals 0 when x is negative 2, right? So I am going to center my table at negative 2, and then I'll just pick a couple of x values that are less than that and a couple of x values that are greater than that. So a couple of x values that would be less than that would be like negative 3 and negative 4. And a couple of x values that would be bigger would be negative 1 and 0, right? All right, so now I am going to plug those into my function. So what you're going to see me do now is just make 5 copies of my function where I'm leaving out the x, and then I will fill that x in just a second. All right, so we're going to evaluate this function when x is -4, when x is -3, when x is -2, when x is -1, and when x is 0. All right, so let's work from the bottom up. I think that might be the easiest way. 0 plus 2 is 2. 2 squared is 4, right? So right off the bat, I know that this graph passes through the point 0, 4. So let's put that right there. When x is -1, -1 plus 2 is 1. 1 squared is 1. So that tells me that this graph passes through the point -1, 1, which is right here. Then we have -2. -2 plus 2 is 0. 0 squared is 0. So we're also passing through the point -2, 0. All right, now, next thing we have to be careful. -3 plus 2 is -1. What is -1 squared? Well, it kind of depends on what you mean by that. Notice that the -3 plus 2 is in parentheses, which means the number I'm squaring is -1. And that means this. You want to be really, really careful here that you don't accidentally do this, because that comes out to something different, right? What we mean here is the square of -1, right? So we do not mean that. The square of -1 is 1. So you see why it's so important that I wanted some x's that make x plus 2 negative? It's because when I move past -2, going to the left, this graph heads back upwards. All right, and then finally -4. -4 plus 2 is -2. The square of -2, like what we just did, is positive. It's +4. All right, so we want to make sure we hit -4, 4. All right, so my graph passes through those points and a whole bunch of others and gives you this sort of U shape. I'm so happy that I found this background. I would never have been able to draw it this well on the other thing that I was using. By the way, this graph is called a parabola. We're going to be looking more at parabolas in chapter 11, and then a little bit again in chapter 13. All right, so next, this would be a good one for you to try. You can do it exactly the same way that we just did that one. G of x equals the absolute value of x minus 2. All right, so pause the video, try this one, come back and compare notes. So I'm going to set up my table. And I'm going to give you the same advice that I gave you about the other problem. Think about the number that makes that inside function equal 0. So what is the number that makes x minus 2 equal 0? That number is 2, positive 2. So I want to pick some numbers that are less than 2 and some numbers that are bigger than 2. So how about 0, 1, 2, 3, 4? Okay. That should be a good enough variety of numbers. Next, I'm going to make my 5 copies of the function, leaving out the x. All right. So we get 0 minus 2, 1 minus 2, 2 minus 2, 3 minus 2, 4 minus 2, and then we're going to take the absolute value of all those. All right, so we'll go from top to bottom this time. Why not? 0 minus 2 is -2. The absolute value of -2, you remember how that works, is 2. Right? So this graph passes through the point 0, 2. Next, we have 1 minus 2 is -1. The absolute value of -1 is 1. So we're also going to pass through 1, 1. 2 minus 2 is 0. The absolute value of 0 is 0, right? So we're passing through 2, 0. Okay, and again, hitting on this idea of a big enough variety of x's. If you stopped after this and said, oh, I have 3 points, that's good enough, you'd get a line, a straight line just slanting down and to the right, wouldn't you? Well, that wouldn't be too good because when I get to this point, the absolute value of 1 is 1, and the 0.31 is up here. See, it turned around again. And then finally, 4 minus 2 is 2. The absolute value of 2 is 2. So that gives us the 0.42. All right, so where the graph in the last problem was a U shape, this one is a V shape. And I've never heard of this graph having a name. The last one is called a parabola. I don't know that this one has a name. I just call it a V. Okay, but it looks something like that. All right, nonlinear functions because the graphs are not straight lines. And that brings us to our last example, which is h of x equals the square root of x subtract 1. And I want to be crystal clear that the only thing under that square root sign is the x. Okay, so for this one, I'm going to do something a little different, okay? I am going to use only nice values of x that'll get along well with that square root. So that means two things. Number one, I am not going to use any negative values of x. Right? What did we talk about a few slides ago? You can't take the square root of a negative number. That comes out to not a real number. And when I'm drawing graphs, I'm only interested in real numbers. And the other thing I'm going to do, this is not as important. I'm going to pick perfect squares, numbers that I don't need a calculator to figure out what the square root of that number is. So I'm going to pick numbers like 0, 1, then I'm going to skip up to 4. And I wasn't totally happy with this when I found this background because I knew that it wasn't going to make this next thing work out very well. But I am going to put 9 on here. My graph does not go all the way out to 9. I tried to find a background that didn't have the numbers already marked on there because then I could have just, marked them off any way I wanted to. And there will probably come a time that I'm going to need to do that, but I think we can get around it this time. All right, 0, 1, 4, 9. So let's make 4 copies of this function, leaving out the x. And when I put those x values in there, see, this is why we had to review square roots. Okay, so first we have the square root of 0, which is 0. 0 minus 1 is -1. So the first point on this graph is 0, -1. Next we have the square root of 1, which is 1. 1 minus 1 is 0, so that's the 0.10. Then we have the square root of 4, which is 2. 2 minus 1 is 1. So that's 4, 1, way over here. All right, and then finally we have 9. The square root of 9 is 3. 3 minus 1 is 2. So that's the 0.92. I can almost get that point. It would be, let's see, there's 7, there's 8. 9 would be just a little bit off my screen. It's going to be, it'll be right about there. All right. Okay, so when we go to draw a nice smooth curve through those points, it looks something like this. And this is technically part of a parabola turned sideways. If I were to have the rest of it would look something like this. Okay, but we don't have that, so I'm going to erase it. Okay, and this is what square root graphs typically look like. They rise up from a single point and just go in one direction, usually to the right, but not always. All right, we're going to be practicing graphing nonlinear functions some more in the next section, and I'm going to share some tricks with you to make it a little easier. So until then, enjoy the rest of your day, and we'll see you next time.